about Hive. In this module, we will discuss the Apache software ecosystem tool called Hive. We will define what the Hive architecture is and talk about some of the basic Hive commands. We will learn how to load data into Hive and how to run queries in Hive. We will conclude this module with a lab exercise, providing an opportunity to apply some of the concepts that we have discussed. What is Hive? Hive was developed by Facebook and is now a top-level Apache project. It is a data warehousing infrastructure based upon Hadoop. It makes data immediately available for non-Java programmers via a SQL-like interface. It is built on what is referred to as HiveQL or HQL, which is a SQL-like query language. Hive interprets HiveQL and generates MapReduce jobs that are then run against the cluster. Using Hive does enable easy summarization, supports ad hoc reporting and querying, and the analysis of large volumes of data using a SQL-like language. Hive is designed for batch processing of large data sets. Therefore, it is not intended to be used as a real-time system or as an OLTP type system. Latency and throughput are both quite high compared to your traditional RDBMS environments. Hive is organized into databases, tables, partitions, and buckets. Databases are traditional namespaces that separate tables and other database objects. Tables are just homogeneous units of data that have the same schema. Partitions determine how data actually gets stored, and buckets and clusters are used for sampling within partitions and specifically for join optimization. The Hive query language provides a basic SQL-like interface and supports most SQL operations. You can use the SQL select statement to select columns and the SQL where clause to filter rows. You can use joins to join tables together, group by for aggregation. You can store query results into another table. You can download results to local storage from HDFS if you wish, and you can manage tables and manage queries with the create, drop, and alter commands. The primitive data types are pretty straightforward, supporting ints, booleans, floats and doubles, strings, timestamps, decimals, and binaries. And in addition to the primitive data types, there are some complex data types available in the form of structures, maps, as well as arrays. There are some limitations with HiveQL. It only supports equijoins, outer joins, and left semijoins. Because it is only a shell for MapReduce, complex queries can and are very hard to optimize in Hive. And Hive is missing large parts of the full SQL specification. Having clauses in selects is not supported, nor are correlated subqueries. Subqueries outside of the from clauses are not supported. HiveQL does not support updating, nor does it support materialized views or stored procedures. Hive Architecture. The Hive architecture is relatively simple, consisting of a client from which to submit HiveQL, a metadata store, the MapReduce framework, and of course a Hadoop cluster with data stored in HDFS. The Hive Metastore is used to store all of the Hive metadata. By default, this is a small Derby single-user database. There are more than one configuration available. One of them is embedded, which is typically for test units. Local configuration, basically each Hive client will connect to the Metastore directly, and you can have a remote installation where each Hive client connects to a Metastore server, which then connects to the Metastore database itself. Hive tables are stored in what is referred to as a Hive warehouse. By default, this is in the user Hive warehouse directory structure. Tables are stored in the warehouse as subdirectories. Partitions are subdirectories of the tables stored in the warehouse. External tables are supported in Hive. The actual data itself is stored in flat files. Here we see some of the Hive file formats. The default delimited text is where each row of data corresponds to a line of text, and you can see as well the default values for the various delimiters for a text file, whether it be the row delimiter or the column delimiter, a delimiter for key value pairs, as well as the delimiter between the key and value of a key value pair. Sequence files are also supported, typical standard HDFS binary format. Because of compression, they are more space efficient than our text. And a new file format type, which is called RC file, is designed specifically for large volumes of data stored in HDFS and does provide some performance benefits over simpler formats. Hive Basics. Hive is a schema on read application. Schema is only enforced when the data is read, which will be at query time. This allows for much greater flexibility in your environment. Same data can be read using multiple schemas if you need to and want to. If you contrast this with an RDBMS system, which is schema on write, schema is enforced in an RDBMS environment when the data is loaded. This does speed up queries at the expense of load times, however.